Okay, so today's going to be just one monitor, and hopefully sound quality is not the worst. Yes, what I wanted to finalize today is the batch stuff. Before we move on to, kind of doing some proper training on these. It's been quite a while. It's just been too distracted with other things, and I hope I'll be able to just remember what was going on. So. Yeah, okay, of course not working because now I haven't finalized that stuff. So the batch size is in positional encoding, improved encoding. Um, I think I think it's down here. It's like if I remove these, I think that works. Yeah, okay, so up until this point is all cool. The multi-head attention is okay. So positional encoding. Let's just go to attention. Um, Positional encoding. We've got the byte size in here, and then yes, exactly. This was preparing these by adding that extra dimension on top. Sometimes I feel like I can't think. I can't. I should not think too much about these, about the dimensions, because then I get lost as in like I try to visualize this in my head, and it just kills me. Um, so this initializes basically this initializes everything, right? So it initializes the byte size, blah blah blah, and then we need to do a multi-head attention. Okay, so now multi-head attention. Uh, so yeah, okay. Well, let's just rewrite it. So let's just basically uh, rewrite this method so it also considers byte size. Mm. So byte size, what has it done? Let's take a look at this first. Let's just compare it. So it has done the same assert. Now it's in the parameters byte size. Byte size is in here, and then essentially we're creating the random values. Yeah, exactly. Per byte size. That's simple. Exactly. No, that shouldn't have a different shape. That's all good. We can remove these. We can actually, this actually should be indented. I don't even have a proper mouse, so hopefully the keystrokes are not killing your ears. Now, and now let's do split heads. Rewrite this function so it considers byte size. And just uh, let's just check that it is actually working. So there's a reshape. I guess um, that's going to be tricky. Batch size. Okay, so batch size stays the same. And then it does this thing. Oh, okay. Um, Wait a second. Let's think about these. So we were reshaping it like by just saying the length of we're just with one sentence in the input tensor. Exactly. And so we were doing the split in terms of the number of heads. We still wanted to have 15 That's wrong. Of course that's wrong. I think you just do. I think you just have the same. So I think you just have the same. Um, Essentially, you just have the same. You have length of x, right? Because no, length of x. Uh, but x now. Length of x 0? No, that's not length of x. Let's put it this way. So here x was um, what it was here. It was basically how many. So x was basically these input IDs, which is basically how many words, and then for each, exactly, and then for each word you'd have the depth, right? The max, it was max len, exactly. It was max len. It was definitely, so it was max len, um, and we need to pass that to, we need to pass this here as well. So yes, because it's max len, that's what we need, because it's the words. So we need this max len here, and we need it in num heads. Wait a second. So how do we have it here? We have d model max len num heads. Does this make sense? And no. D model. Oh man. D model max len. So how do we have here? Max len. D model max len batch size. And I would say, just to keep that consistent with the other function, and then num heads here, right? Because that's the last thing we do. D model max len byte size, and so here should be D model max len byte size num heads. Correct. So exactly. And then max len should also just be something that it's just stored as a property, and then because we have this max len here, then that's what it should be. Which is better than what we had before, because before it was just a workaround not to pass max len in there. But that's the idea, right? So max len is the max len is how many words you want to have max, and here we're gonna have 15 words. So byte size max len. So reshape. So it's exactly. So we're adding this. This is the reshaping. We're adding this num heads, and then we're keeping here the first one byte size. I don't think this makes sense. So I think that 0 stays as it is, right? And then I think we just need to do 2, correct? The num heads, then max len, and then here it was basically, yeah, we're keeping the last one. Yeah, I think that's correct. That's correct. Yes. So yeah, so we're swapping heads with max len. Oh man, that's complicated. So swapping heads with max len. Num hits. And then stack the byte size and now has access to create a single head dimension. What? Eh, I think that's just not needed. I almost didn't even keep any of these. Um, I'm already returning these, so I'm just gonna assume it's correct. I've just added the byte size. That's all. That's all I've done. That's all I've done. I've just added the byte size so that you can have multiple sentences, but then this kind of splitting and all this kind of stuff is happening inside. So then the call shouldn't be, I think the signature stays the same. You're doing this map mole, whatever it is, you're doing the split heading, and now you're doing so the dot product attention. Um, so what is it, the dot product attention doing? Okay, so this is where it gets tricky. Because here's, I don't know why, what is this? -1. Um, so what is this statement doing? Is it calculating the size of the last dimension? Um, so this is the last dimension is the depth, isn't it? So it's doing what it's doing is taking the scores, which is multiplying. Okay, so what are these? That's definitely here wrong. So dot product attention QKV. It's supposed to attention weights. Let me ask it to rewrite it as well. Rewrite the following function, knowing that um, that Q, K, and V now have a batch size dimension at the front. That's the right. So an attention pi. I think let's hope that works. Wow, that is actually significantly different now. Extract the hidden size of the query tensor. Input for both query and key matrices have the same shape. Compute the dot product between the query and key tensors and scale by the square root of dk. I just don't know why this is happening, but apply the mask if it is provided. Okay. Let's first see if that works at all. I was not anyway sure about, you know, these function working anyway, or doing the actual thing anyway. So is the sound coming through? Yeah, sound is coming through. I think I have everything, right? Tension weights, and now there is the, exactly, so here's the thing, right? So attention weights now, let's just sentences. So attention weights, attention weights. What is these? Attention weights 1, attention weights 2. Where do we have 2? What do we have 2? Files I forgot. So attention weights. I guess let's just try one thing. I forgot actually sentences. So let's just say we want to calculate for sentence 0, right? Sentences, sentences, sentences. And I believe this is going to be something like this, because I think now attention attention weights concat attention. Oh my god, I don't know if that's going to be attention weights. That part, attention weights. I completely forgot what is this doing at all. This is an extra stuff, an extra multiplication thing, but this concatenation, completely forgot what it's doing. And my guess is if I hit run, that is definitely not going to run. So where is it breaking? In MHA call. In cannot reshape array of size 600 into shape 260. So where is this in reshape? Reshape, applied attention, concat attention. That's what it's saying. Yes. So let's take a look at. Let's take a look. Can I comment on this? Why is this correct? So let's again, like, I'm not commenting a lot because the truth is, what else is missing here? Okay, because we don't have concat attention. So let's not return anything, but let's just attention weights. Print attention weight shape. So what do we get? 4, 2, 15, 15. Okay, so 4, 2, 15, 15. Ah, yeah, that's what we're multiplying. Yes, because we want to connect this 15 again. So 4 is the batch size, isn't it? So that's been correctly, I think the batch size is 4. Yes, so that's fine. Um, okay, why is it breaking? Oh yeah, because it expects a return thing. So force this, and then now what we want to do is basically um, we just don't want to have these. We just want to have 4, 15, 15. I think that's all we want to have, right? Right? Is it all we want to have? 4 by 15 by 15? Mm, should be 10, shouldn't it? No, it should be 15 because that's the tension weights. Yes, 15 by 15. Correct. I think I had the same question last time. So that should just be, the concatenation should be a reshape. That's correct. Um, mm, 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 mm. And why apply the tension? Okay, wait a second. Wait a second. Uh, tension weights. we should also we should also reshape the attention, shouldn't we? Because we don't want these num heads. That's why I was doing two things: the first head, the second head. So we want to have, sorry. So we want to first of all apply the tension. So let's just print apply the tension. So applied attention is 4 to 15, 5. Correct. Exactly. Yeah, that makes sense because it's two heads. Each head has half the depth, and then there are 15 words. And we want to have, and we want to have, we want to have 4. We want to have 4, 15, 10. Exactly. So we want to have. So we want to have this. I just don't get the. Why cannot I just. So give me a second. No, didn't want to. Okay, so we want to have conquered attention. It's applied attention that we're reshaping, and then we want to have. Uh, obviously, we want to have the same first dimension. That's fine. 4. Okay. Then we want to have the second. Uh, the second is basically 15. So the second is 15. So this would be. Okay, before I was doing like okay, yeah, so this will be 2, right? So I want to have 15, 0, 1, 2, and then I want to have 1 times 3, because that gives me the 10, exactly. That's where it was coming, exactly. 1 times 3, exactly. And now, why am I getting a warning? But it's never used. Okay, but that's fine. That's not a problem. So, and I think basically we can also just, we can also conquer attention. So now we use it for the output, and I think the attention weight should also be reshaped. attention weights should also be reshaped. So attention weights should just be reshaped by just saying we want 4 and then we just want 15 by 15, right? We just don't want the two heads. So this essentially is 4 and it's like shape 0, 1, 2, 2 and then attention weights shape 3. So we just want to skip one dimension and just put them together. Although, to be honest, to be, to be honest, the way reshape works is just pure magic. It's pure magic. And then we return these. So now at least this shouldn't break. And before we do any of these, let me just let's print the shapes. Can we print attention weights shape? And can we print the output shape? Why? So this output shape. Can we do these? Okay. An array of size 1800 for 15. So there's something wrong in here. So where is it going wrong? 42, 15, 5. That is definitely this print here. And so this seems to be okay if I just do print the very good debugging capabilities of Python, of proper Python developers. Yeah, exactly. Do I get this? Yes. What I don't get is past that, probably. Very nice indentation. Test 2. That's probably what I don't get. So that's why it's breaking. Yeah. Why? Why don't I? Why can't I reshape it this way? So what is the? Maybe that's why I gave up last time. Tension weights shape. It's 4, 2, 15, 15. So essentially I want to get rid of these two, right? Why cannot shape it at 4, 15, 15? Hmm. 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 Why I cannot shape it like this? Why I cannot shape it like that? I just don't know. Don't get it. But okay, I can't. I'm fine by just fine. I can do that, but like for now, why can't this be reshaped? That's kind of like a bit of my current. I probably should dig into how reshape works. It just would be interesting. If I do these, then it's all good. I just don't know why I can't reshape it like that. But okay, now I have definitely multiple. Let me delete these attention weights. So, and now I guess I can just finish it up the same way. So I can just say, for example, print attention weights. So we want, but of course the attention. So So here's like well, yeah, attention weights. So I'll just yeah, the heads kind of bother me that I cannot combine here. So I'll just have to do 0, 0, and then I get that stuff. Yeah, exactly. So yeah, that should work. 0, 0, and then you know, with the sentence 0, right? Because this is first dimension, and then this is the no, here this indicates a sentence, and this indicates the head. So here is sentence 0, and then if I want to do sentence, let's say 2, then it's basically, yeah, correct. That was a good suggestion. And then I will just do the sentence 2. And let me clean up these tests. We don't want to have these tests prints in here. It's too many prints. Cool. Yep. And now if I run these, I get these perfect. And now I can take a look at it and open these with the CSV editor and then check. Well, this should still be random, but at least, yeah, okay. But at least it's like the brown fox, right? If I open this one, I just say, it just should say something else. The quick brown dog, exactly. All right, all right. So I think we're done with the batching. We're done with the batching, but there's still a question of why can't I just, yeah, well, because how can I combine them, right? So two different heads, each head has different attention mechanisms. How do I merge them? Mm. Yeah, but then how are they applied? Which ones are applied? When you do the when you apply the thing, when you apply the, I hope I've turned the microphone on again. When I apply, we split the heads, apply the tension happens in here. Tension weights, the output, tension weights. Okay. You multiply attention weights by V. This is still, I'm not so sure how this works and why this outputs something that is then reshapeable. That makes me feel, obviously, a bit more uncomfortable. But what can we do? I think that is everything. Yeah, that is the best we can do. So, cool. Batch hazing is done. There are two things, right? So on one end, it bothers me that I don't fully understand how the reshaping is working and why I can't reshape the attention weights. And on the other side, then let's kind of move on to the actual training of these. Perfect.